Hi everyone, today we are going to be discussing the topic how to apply climate responsive design to sustainable buildings. What is a sustainable building? It is an integrated process that focuses on the relationship between the built environment and the natural environment. Buildings can have both positive and negative impacts on their surroundings, as well as the people who inhabit them every day. Reduce the energy and water use, healthy indoor environment quality, smart material selection, and the building's effect on a site are the key consideration of a sustainable building. Building 1987, 40 Albert Road was like many typical energy and water-hungry commercial buildings. Nearly 20 years later, Zen Group had transformed the building into a cutting-edge green building. Energy and water use has been reduced dramatically, and the building now harvests energy and water for use on site. Roof acts as a mini power station that generates energy for the building. Solar panel and solar hot water convert the sun's energy for use within the building. Water use is minimized by using water-efficient taps, toilets, and shower heads. Rainwater is collected from the roof and stored in the basement. Green water from the showers and hand basins is treated and mixed with the rainwater to flush the toilets. Each building is equipped with occupancy sensors so that if people are in them, lights and air conditioning are active if needed. In the first year as a green building, 40 Albert Road made the energy saving of 61% and the water saving was 82% compared with the industry average. In the second year, the result was improved with energy saving of 71% and the water saving of over 90%. The most effective implementation of climate-responsive building is achieved using a series of detailed analyses. For example, environmental analysis, it looks at historical temperature, humidity level, and solar radiation to improve the climate-responsive feature of the building. Layer analysis of the interior space helps to determine the areas and durations that will be subjected to direct sun glare. This analysis can be contributed to around-the-clock energy saving by dynamically changing with the environment.
Now we come up with two solutions to apply climate-responsive design to sustainable buildings and further optimize them. First, smart glazing system. It can actively control how much solar light and heat transfer into an interior space and minimize solar heat penetration in summer months to reduce a building's cooling load. Conversely, it can be used to maximize solar heat gain during winter months to help reduce the amount of energy needed to heat the building. A high-performing system can help climate-responsive projects effectively manage heat gain. Second, dynamic window system. Strategic building orientation and data-informed fenestration can maximize the climate-responsive abilities of buildings. Install a dynamic window system for buildings to respond in real time to dynamic features such as sun angle and sky conditions. While preventing glare by automatically changing the tint mode of glass windows, balancing sunlight levels, and managing solar thermal gain. It can be programmed to automatically respond to changing environmental conditions or can be manually changed according to the user's need. The system will enable buildings to access high-quality daylighting and reduce the energy consumed by artificial lighting. Today's architects and builders are increasingly focused on how to create structures that have less impact on the natural environment. The goal of climate-responsive architectures is to create a comfortable interior environment while reducing the building's reliance on artificial energy and further realize sustainable building. Thanks for watching.